Hello and welcome. Take a look at my answer key for example 2 and example 3 here. Right? Expanded, counted up on my bases, same bases, right? But take a look at example 4. What's different about example 4? Absolutely. We have two different types of bases. We have x as a base and we have a as a base. Is that going to change the rule? No. I still see common bases here, right? Just like you have combined like terms sometimes, look for common bases. Okay? So let's take a look at my x's first. I'm going to expand this as x times x times x times x. And I can use, since we're multiplying, I can use the commutative property to put all my x's together. Times another x. Right? You're multiplying all this through. And now I can take care of my a's. Times a times a, right? And then I have another times a times a times a. Just like when you're adding, same with multiplication. You can use the commutative property here to put your like bases together. Right? So now tell me what do you think the answer is going to be. Pause the video, try it on your own. If you didn't get it the first time, that's right. It's going to be 1, 2, 3, 4, 5. X to the fifth power, 1, 2, 3, 4, 5. Times a to the fifth power as well. You can put a little multiplication here if you want to, but you can put them together. X to the fifth times a to the fifth. Same thing, right? So now, boxes, take a look. It says, would expanding the expression be the most efficient way to solve examples 5 and 6? Why or why not? First of all, where's example 5 and 6? Go ahead and flip that page. All right, now, it says, would expanding work for examples 5 and example 6? Would that be efficient? Well, I see this is negative 7.2 to the 17th power, to the 31st power, to the 50th. I don't think expanding would be very efficient here. Why do you think expanding wouldn't be efficient here? Look at your powers. Look at your exponents. That's right. It wouldn't be efficient here because I'm not going to sit here all day and write out negative 7.2 52 times. That's crazy. But what pattern did we learn when you're multiplying exponential expressions with the same base? What pattern did we learn on the previous page? Absolutely. You can just do what to the exponents? Turn back if you don't remember. That's right. You can just add the exponents. So let me show you what that looks like. We have the same base here, right? Negative 7.2. And I'm going to add my exponents here at 17 plus 31. Look at the formation. Look at the organization here, right? And now I can add these bad boys up, right? Now this is going to be negative 7.2 to the what power? Absolutely. If you need to take out your calculator, go ahead and do so. It's going to be negative 7.2 to the... I'm doing some mental math here. 17 plus 31. Actually, let me get my calculator out. I don't want to waste your time. 17 plus 31 plus 52. You should have to the 100th power. See, I'm not going to write that out 100 times. That'd be crazy. So my answer is negative 7.2. Don't forget your your parentheses because it's given to you there, to the 100th power. Okay, go ahead and see if you can do this next one on your own using that the product rule, the multiplication rule that we just used. Okay, and I'll see you in the next vid.